Good, good morning or afternoon, as the case may be. Today we're looking at our 7.7 notes, factoring special products. We've actually talked about this a little bit already, and I'm just going to show you a couple things that we did discuss. For example, using our box, if we wanted to take this the product of these binomials, a plus b and a minus b, which if you recall were we called conjugates because one was a plus b and one was a minus b. They were very alike except for the one sign that changes. So if we were going to fill our box, we would do a times a to get a squared. We would do a times negative b to get negative ab to fill this box. And in this box, we would have a times b. And in the last box, we would end up with negative b squared. Okay, so as it turns out, and this is what we talked about with the conjugates before, that the things in these two boxes always are opposites. So what happens is they're going to eliminate each other as opposites when we combine the things inside the box. So the result is a squared minus b squared. Because that's got subtraction, that's why this is called a difference of two squares. So we end up with a squared minus b squared. Now I don't like what the book puts right there in that pattern, and this is a pattern, and you can see on this second example that we would be thinking about multiplying the products of x minus 3 and x plus 3. Those are again conjugates. So in this box would be x squared, in this box would be negative 3x, in this box would be positive 3x, and then in the last box we would get negative 9 from positive 3 times negative 3. And so we end up with x squared. This, again, those are opposites in the corners, so we end up with x squared minus 9. All right, so let's apply that to, apply this pattern to some of these other problems. So, for example, this part A here, the pattern is that a squared minus b squared can be broken down into the factors a plus b and a minus b. So in this case, x is in the place of a. So instead of having a squared, we have x squared. And so we're going to have x and x as the first term in both of our factors. And 5 is playing the part of b, because 5 squared is 25. We can think of this as 5 squared. So that means that we can break this down into x plus 5 and x minus 5. All right, another way to think about it, and we've discussed this before, was that this is a binomial without a middle term that we're used to seeing. So one way to think about it is that we're looking for a pair of numbers that has a product of negative 25 and a sum of 0. So there it works out. In example B over here, this time the thing that is being squared here is actually 2x. If you think about it like that, 2x squared is the same, 2x squared written this way is the same thing as 4x squared written this way, because you're going to square the two. So in our parentheses for our factors, we're looking at 2x as being the leading term for each of those. And you can see that if we went backwards and did 2x times 2x, that would be 4x squared. And then for minus 1, 1 is the square of 1. This is 1 squared. So we'll complete our binomial factors with a +1 and a -1. Okay, so we end up with conjugates. If we start with a difference of squares, we can factor it into a product of conjugates. Okay, over here we have x squared minus 64. X is being squared, it's playing the part of A. 8 is being squared, it's playing the part of B. So we could write x and x as the leading coefficient, or the leading term of each binomial. And then we can do 8 and 8, one of them which is plus and one of them which is minus, to complete our factors. Okay, so we started with a difference of squares, and we end up with a product of conjugates. Okay, example D over here has 5x being squared and 6 being squared. So it's a difference of squares, and so it can be factored into a product of conjugates. So 5x is playing the part of A in this case, and 6 is playing the part of B. So now we can write this as 5x plus 6 and 5x minus 6. So once again, we have a difference of squares, two square numbers being subtracted, and we wind up with a product, or factors of conjugates. All right. So there's 4 differences of squares for you to try at the bottom of the page here. Your sub is going to pause the video to give you a few minutes to work on that, and we'll come back in a moment and check your work. And we're back from commercial, and here we have a difference of squares, so we're going to factor it into a product of conjugates. X is playing the part of A, and 6 is playing the part of B, so we're going to write x plus 6 and x, minus 6. That's a sloppy minus, sorry about that. Over here, 100 is playing the part of A, and so, 10 is playing the part of A, so the square of 10 is 100, so 10 is going to be playing the part of A, and x is playing the part of B this time. So we'll have 10 minus x and 10 plus x. And don't worry that that's not in standard form, the way this is written at the beginning. I find it's easier to factor things that don't have a leading term that's negative. And so this is a square and this is a square, and we can factor that as a difference of squares. On number 3, 3x is playing the part of A and 4 is playing the part of B. So we can factor this difference of squares into this product of conjugates. So 3x plus 4 and 3x minus 4. On number 4, we have 4x playing the part of A and being squared, and 7 playing the part of B and being squared. So we can factor this difference of squares into this product of conjugates. Okay, there we go. And we're going to stop this video because there's a limit to how much can be saved.